So guys, in this video we are going to see another type of rate of a reaction called as instantaneous rate of a reaction. So in simple words, let me explain you what is the main difference between that of your average rate of a reaction. So in average rate of a reaction, we were knowing that whatever the rate of a reaction we were calculating, that was with respect to certain interval of time. But in instantaneous rate of a reaction, what we are going to study is at that particular time. We are not going to see the interval. Instead, we are saying at that particular time, what will be the rate of a reaction. Then how can we study it? Basically, first we have to understand the definition of it. What does it say? It is the change in the concentration of your reactant or the product involved in the reaction at a particular instant of time. So that is called as instantaneous rate of a reaction, as we have explained earlier. But this part, whatever the rate of a reaction of your instantaneous is there, that is mainly done with respect to that of your graphical analysis. Because whatever the instantaneous rate is there, that is mainly given by minus of dr by dt, or which is can be also equals to d of p by dt. Of course, we know that it is the rate of change of the concentration of your reactant. Similarly, it's the rate of change of the concentration of the product. This d by dt is nothing but the slope of a tangent. So when it comes with respect to slope of a tangent, it strikes to our mind that of course there should be a graph related to it. So when I see, of course it is similar to that of the molar concentration or that of your average rate of a reaction, that is molar concentration of your reactant versus time. When I plot it, of course I am going to get the curve as we have obtained with respect to average rate of a reaction. But instead of over here taking as the time interval, what I am going to do is I am going to draw a tangent. And for that tangent, when I am going to calculate my slope, for example, for this one, this part, this small part along your y-axis will be your dr, and whatever this part is there, that will be nearly equals to dt. So whatever the slope I am going to get will be what? dr by dt, which will be a negative. That means what? With the passage of the time, the concentration is going on decreasing. When I plot a graph for that of your molar concentration of the product versus your time, of course it would be in this way. So for this one, what we are going to see, so when I draw a tangent over here, yes, a tangent over here, and I'm going to calculate it's in this way. So this is going to give you as a dp divided by dt. So here the slope gives us what? The change in the concentration of the product with respect to that particular time. You can ask me, sir, here we are saying as a d alpha. This d is a very small interval of time. Remember, whenever we are using the word as delta, the difference will be very large. But when I am using the word as d, of course, this will be what? Difference will be very small. So we can neglect that difference itself. For what that particular interval of time only it would be giving. And whatever the rate we are going to calculate from the slope of a tangent with respect to the molar concentration of the reactant and molar concentration of the product with respect to the time, that will be given as that of your instantaneous rate of a reaction. So this is the main difference when we come across average rate of a reaction and instantaneous rate of a reaction. So coming to the next part, which is called as unit of a rate of a reaction. Unit of rate of a reaction. Can you please help me to give its unit? Of course, we have seen rate is nothing. In simple words, if I have to say, It is the concentration by time. Yes. So what we can say of the concentration in SI unit? It is mole per liter. What you can say with respect to the time? Of course, it is your second. So overall, what I can write it as a rate. Remember, it's a rate of a reactions unit I have written. It is mole per liter per second. Able to understand? So unit of a rate of a reaction is mole per liter per second. Very much important. For 1 marks they can ask you, and you remember it is the unit of a rate of a reaction. Why I'm saying again and again? Because one more unit you are going to see, which will be a unit of a rate constant. We don't want that part now for a while. We have to just focus on that of your unit of rate of a reaction, which is given by mole per liter per second. So in our 2 videos, we have mainly discussed that what is a chemical kinetics. So chemical kinetics is a branch of a chemistry which is saying us, or which is explaining us how fast and how the reaction is taking place. So with respect to the chemical kinetics, we have also seen what do you mean by rate of a chemical reaction. It is nothing but the rate of the decrease of the concentration of your reactant per unit time, or rate of the increase in the concentration of the product per unit time. So there are mainly 2 types: average rate of a reaction and an instantaneous rate of a reaction. Average rate of a reaction means what? It is the rate of a reaction we are calculating with respect to the time interval. Yes, of course, when you are coming with respect to the instantaneous rate, what is happening? We are calculating the rate of a reaction at that particular instant of time. So that will be the main difference between the two. Coming with respect to the sign convention, yes, if there is a decrease, if you are measuring the rate of a reaction with respect to the reactant, the sign convention should be negative. Okay, the negative sign indicates that with respect of the time, or with the passage of the time, the concentration of the reactant is going on decreasing. Whereas with respect to the product, of course, it will be positive, because with the passage of the time, the concentration of the product goes on increases. So coming with respect to that of your unit of a rate of a reaction, yes, so it is given by concentration by time. So concentration SI unit is mole per liter, whereas time is seconds. So overall unit I am getting it as mole per liter per second. So this is the main part we have to understand first when you are going to the top of your chemical kinetics. So in our next video, we are going to see what are the factors which is going to affect the rate of the reaction, and how does the stoichiometry of the reaction will be related to that of your rate of the reaction. So depending upon these things, we are also going to see certain problems based on average and instantaneous rate of a reaction.